There are two type of copies in Python. One is called shallow copy, one is called deep copy. So copy returns a copy of list. Let me tell you how. So first time these two things. A shallow copy create a new object which store the reference of the original elements. So I told you that referencing thing. Suppose you made a variable, you made somewhere you put in your room a bucket, okay, and then uh, there's a reference that how to reach that bucket from two different ways. That is like a shallow copy. But if you will fill the bucket, so when suppose if you will fill the bucket with water, that was initially it was empty bucket. If you fill the bucket with water and two people are coming to the same bucket, they both see the changes. That is called uh, the uh, shallow copy. It creates a new object which store the reference of the original element. Then one is called a deep copy. And a deep copy create a new object and recursively add copies of nested object present in the original elements. So deep copy is something like you made the reference, but it is not changing the original one. Let's see. So this is the list, and then list two equal to list one. This is a shallow copy. If you append something in list two dot append this thing, and then you want to see you want to print the list. First, see this. It's a list one. You said assign list two with list one. Make changes in the list two. If you will print the list two, you can also see the changes in list one because this is just a shallow copy. This is not it is not like if you will make the changes only in list because you just appended item in list two, not in the list one. So you appended in list two, and then the changes which can be seen in the list one as well. That is a shallow copy. Now, if you will see the ID of list one and list two, you can see the IDs are same. That's why the reference to both of these things are same. One is called deep copy. So the syntax for the deep copy is you have to import the copy module in Python, and then you have to say copy.deep copy. So this is my old list, which is a 2D list of list. You said make a new list, okay? And then now if you will see, I am asking print old list and new list. You can see that both look same, but if in the new list you have appended something, now you're again trying to print the new list and the old list, you will see the only change will happen in the new list because you have made a deep copy. So your original list is preserved, your old list is preserved. So this is how the copy things work in Python. If you have to make a deep copy, then you have to always import this module and say copy.deep copy. Generally assignments, this is just a simple assignment which is by default is a shallow copy. Now this count method which returns a number of element with specified items, like how many times that particular element appear in your list or in your retrieval. You are saying count how many times hello came. So you can see it returns you something. That is why it is saying print 3, and print is itself a function. That's why it is giving you the 3 as an output. So it is working like this is the answer variable you have created, and then you are saying print answer. You are saying print answer. You are saying print answer. Now, as you can see, this method is returning something, and print method itself internally catch that value and give you the output. So that's why you can't see the hidden details, but as now you can see this print method, this count method returns something. It returns the how many number of time an element we can is popped up in a particular list or tuple or any table. This count method work on other d types as well, data types as well, we can see. So this is one more thing which I want to tell you. List typecasting any table as list, create a list out of a table, string, tuple, whatever. What this means. You have this data type. I told you in previous class as well. You have this data type, which is a tuple. You want to typecast a tuple. Listing. You want to typecast a tuple to a list. You are printing it. Print B. Okay. So you can see this is of class tuple, and print B, it is like Oppo, iPhone, Vivo. Initially it was tuple. Now it's become list. So list, if you just put this list, it work as a typecasting. Okay. Or I have used another word as well previously. So for this thing, I mean, typecasting you can understand, but typecasting is on a, you are just typecasting the whole data type. So the word which I used was a constructor. Yeah, constructor. Now the list keyword is working as a constructor. It is constructing the list from a tuple. You can do this with the string as well, but suppose you want to typecast this dictionary to a list, you will see it just taken the key, not the value. As we have previously seen, it will only take the key. It will not take the value. You will see it will only take the key when you want to typecast. In the same way, sum is also a function. What you can do with sum, you can you are what you can do with sum. Mute. Okay, Nishad, can you please mute yourself? Okay. Then what happened? As you can see, there is a sum. There's a sum function. How this work? Suppose you want to sum the all items in the list, and this is the internal working. But if you just want to use sum, you can do something like this is your list. Print sum of A. It will give you the. It will iterate on every list. It will iterate on every item like this. Iterate on every item like this, and then add it to a variable. For the confusion, I'm just putting S. Add it to a variable which is sum. Initially sum is 0. So you will see this is how this sum is working. Go at each item, add it to a variable. Variable is 0. Initially S equal to 0 plus I 96. Now S become 96. Your variable I move to the next move up. Now it is 79. You are seeing 96 plus 79. It is giving you the 189 as output. One more method you can use, which is min, or one more function which you can use, which is a min function. So what does do? If you are providing this integer items and you're asking, give me the minimum element out of this. Give me the minimum element yeah, you are saying give me the minimum element out of this. So it is giving you 65 as a minimum element. Okay. Okay. So it is giving this 65 as a minimum element. Same way the max work. But let's try this min max on the string. How let's see how it goes. So it is saying Karthik is minimum in comparison to Rahul. And I told you in previous class how this minimum and maximum is counted on the basis on in case of a string. There are some priorities it take, which is the ASCII value, the addition of the it will add the ASCII value of every element, and then it give priority to the capital one, a small one, something. And then mostly I guess it is the ASCII value. It is just checking the ASCII value of this one. If it is less in comparison to this, then it is saying Karthike it is saying the Karthik is maximum or minimum. This is how it's working. Then there are some more advanced methods, which is map, filter, reduce. So you will see, if I have to show you map, filter, reduce, I guess this is the flag thing I have put. And flag after flag, I guess I will study the tuple. Automate. Okay, cool. Let me finish this off today. Map. Okay. Let's come to this map. So let's first read this. This map is a function which take a function as an input and a iterable as an input. This map is a method which take function as an input and take a iterable as another argument. The two argument, a function itself and a iterable. It returns a iterator. Iterator means on which you can iterate using for loop. Just understand this. What is a iterator? The data type on which you can iterate using for loop. You can go up, down, whatever. So it returns an object of iterable. It returns a iterator. What are iterators? List, tuple, set, dictionary. These are iterators, and it returns an object of iterable. Like we will see when we let me run this code, then you will see, understand this. That so this method apply this function to each item of our iterable: string, list, tuple, set, dictionary. Let's see how. This was list, okay, and forget this. This is a map function, and this is a lambda function. Lambda are short-handed functions which you write instantly. I mean, you could have write something like, instead of what it is doing, it is multiplying each element by 2. So you could have made a function and then pass this and then see how it is working. But this is a shorthand function, which is a lambda function. You are saying x apply what you have to do with each x is a variable which is pointing initially to 2. What you do, you just have to multiply it by 2. And then where you have to do this multiplication? On the list 1. If you will see print output, when you will see print output, it returns a object of iterable. So it has returned you this object. What was the object? Map object. So here what I'm trying to say, this is my iterable, this is my function, apply this function on this iterable and returns me a object of iterable. Now what it has returned? It has not returned a list, it has not returned a tuple, it has not returned a string. What it has returned? It returned a object of iterable. So this means there's something in your room on which you can iterate. You don't know what is that item. That item could be car, could be bike, could be plane, anything. But you know that you can fly with it. Okay. These are shorthand functions, lambda functions. We will see in next classes this shorthand function as well. But let me tell you. So this is what it returned. Now what I am saying, print, it has just returned me this object, this thing, you can see this thing. Now what I am saying, print list and then put this output. Just as simple as this. It has become list. You said, okay, because this is an object of iterable, I can put any iterator. You are saying this typecast this, interpret this object as a tuple. You are saying tuple. This is why it is useful. tuple. It become a tuple. You are saying no, make it a set. Because it is an object of iterable, you can use what are the any iterator. You make it a set. But if you say make it a dictionary, make it as a dictionary, it will give you error because cannot convert dictionary update sequence to a sequence, because initially it was a sequence, but if it would be a dictionary, then you could have done something. So this is how this map method is working. Let's see more examples. Here what we did multiplication. We multiplied each number by 2. We multiplied each number by 2. Let's see this thing. Here what we can do, uh, here what we can do, here we are saying this is my list, add, go at each element, this lambda x tends to x plus 2. This means initially my x point to 2, then 3, then 4, then 5, then 6. What you have to do at with each element, just add 2. Give me the output. It will return me what? An object. I can interpret this object here as well. Interpret this object as a list. I just told me, give me the list. Whatever I was doing here separately, you can see here. What it has done, it just incremented every value by 2. Initially 2 become 4, 3 become 5, 4 become 6, 5 become 7, 6 become 8, and it become 10. See one more example. I mean, how this internally is working, I have shown you here. I'm saying I'm writing an increment function. I'm passing a list 1. My list 1 is here. I'm passing my list 1. And I'm saying just increase each element by the value 2. Here I'm iterating on my list and increasing each value. First, I have accessed that value with the help of index access 2. I have increased that value 2 plus 2, 4, and I have at the same index 0, I have put that value, assigned that value. So this syntax is used for assignment, for accessing. As I told you, pass the index and the list, you will get that value. Here I did something with the value. Here what I'm saying, go at this index value, assign it with new value. Simple. This is how this increment is working internally. As you were seeing this much line of code internally, something this was happening. If you will print this function, you can see the same output. But these are the lambda functions. This x equal s tend to x plus 2, which comes into very handy. Instead of writing this whole function, your own function, you can just use the lambda. I mean, you can also pass your increment function here, because it is asking for a function. You can also write increment here, and then your list will work. So you can interpret an output like a list, tuple, set, string, whatever, as I've shown you. So this is how this map function is working. It is not mandatory, again I'm repeating, that you just have to write the lambda function. You can like the way you have made your own incremental function, you can put your function as a first argument here, and then put your list. Okay. One more method is there, which is filter method. Which filter method is like, a function is there, iterable is there. What it do? Construct a iterator from the items of iterable that satisfies certain condition. What this means? These are the name of my friends. What I have to do? Filter every name whose length is greater than 4. So it will apply this function. It will apply this function to every item of this list. What is the function is saying? Just iterate on this array initially name is pointing to John. Calculate length of John. If it is greater than 4, take it. Not greater than 4, leave it. It returned me a constructor of iterator, or just you here whatever it has returned, the object of iterable or constructor of iterator. What I said, constructed as a list, it did my work. Constructed as a tuple, as a set, it did my work. Okay. So, okay, why it is giving error? I guess because I have constructed list. Then say, okay, now, and then make it a set. So yeah, this is what it is doing. The filter function, how this is working. So map, filter, reduce, these are the higher order functions which we call in Scala, because in Scala programming, you mostly use the lambda functions, map, filter, reduce, which are higher order functions. Higher order functions means you can pass a function as an argument. You can pass a function as an argument as well. You can search on internet what are higher order functions and you can see. Then we have seen map, filter, and then this is reduce. What does reduce do? Reduce is like apply a particular function passed in its argument to all of the list element. Here what you have observed, it is returning you something. It is returning you a list. It is returning always. It is also returning you an object. But this reduce just return you a single value. How? See, you are saying function sequence. Sequence is their length of rod. Function is what you have to reduce, x comma y, x plus y. It is like 75 plus 65. Then you got a sum. Then add 80 plus 95, something, something, and then you got the sum. If you print it total, it will become 365. So it is saying add two values, x plus y, then again x plus y, then again x plus y, then again x plus y, and then give me the answer. You can figure out like what are the values it is adding. Is it adding this, or this, or is it adding output of this with this, output of these with these, then output of these with these. You can check your calculation, check your mathematics. It's up to you. This is how the reduce function work. And this I have to tell you this iterator concept. I will tell you. Let's see one more method, all. All always return the Boolean answer, which return true if all element in a iterator satisfy a certain condition. Okay. Here you are saying 1 hello 0. You will see it is giving you true because 1 exists, hello exists, 0 exists. Because but if you put 0, and I told you earlier, 0 act as a false, or you will see it will giving you false because some element are false. How you can use this all method? All method is not used like this. All method is something like if every value of your array satisfy a certain condition, if every value will give you true, then use the all method. You will get the output as true. So all method I have used in place of, okay, let me tell you an example. Okay. Answer if I make an API call. API call to do dash. If my API response is true and API call to do dash, API call to Zomato, and API call to Uber Eats. If my transaction is successful from everywhere, if all of this is true, it only enters at the if loop and do something. Do something. So I can initialize do dash, comma, Zomato, comma, Uber Eats, equal to API response 200, 200, 200, and instead of 0, everything is true. If you will see, it is entered inside the if loop because all of them are true. It is saying, yeah, do something. But if suppose the API response code is error is 400 or there are many errors, suppose say error is 0, then it will not answer inside the if statement. Then it will not enter inside the if statement. Yeah, take exactly one argument 3 are given. Okay, in the way I have provided this argument, which is wrong. But yeah, this all works something like this. If all the values inside your this is true, this I should have made it as an array to be true. These are the API response. Do dash API response. Do dash API. If all the API responses are true, okay, then do something. It will not enter inside if because 1 is false. But if all the API response are true, then go inside it. This is how the all functions work. One is like any, it will return true if any of the element of an iterable is true. If any element satisfy a condition, then it is true. Any element, that is true. If every element is false, okay, every element is false, then it will print false. This is how this all and this working. This all and any method are working. Now let we see this ITER, and then I will finish our today's class, and then we will see tomorrow. Next week. Okay. Iterator. What is this? What is this? Iterator. Okay. What is the ITER? ITER like function. ITER is a function which convert an iterable into a iterator. We request for the next value until we hit end value. So here you was getting the object of a iterator, and then you started iterating on it with the help of for loop. You just starting iterating on it. You come to Apeksha, Preeti, Rahul, and yes, you started iterating. But what happened internally? Here you will see. Here I'm just telling you how this internally for loop is working, something like that. This is my array. Print each value. Okay, print each value. It's very straightforward. It has printed each value. Now, with the help of iterator function, what you are saying, you got the method, and then you got the method. Here you will see. Okay, this iterator function, what it takes as argument, it takes a object and the sentinel. What this sentinel means? Sentinel specifies the value that will determine the end of the list. This iterator internally take the object and the sentinel. Sentinel is already defined. How? I can tell you clearly. Forget this for loop. These are some advanced concepts which you should keep in mind. This is my array of bike names, and I have used this ITER function which converts an iterable into a iterator. I know that I can iterate on the list because this is a iterable. I want to convert it to a iterator. Iterator means we request for next value until we hit the end value. Now it has become a iterator. Iterator list. I'm saying print iterator list. It has making a iterator object. It has making a iterator object. Now, how to access the item in case of iterator object? Internally, this is how the for loop is implemented with the help of iterator. Let me ask for next element. It will give me the first bike name. Let me ask for the next element. It will give me the second bike name. Let me ask for the third object. It will give me the third bike name. Let me ask for the fourth object. It is giving me the next bike name. Let me ask for the next object. It is giving me the this. Let me ask for the next object. Now it is giving me until this. It is giving me R7. And I can see R7 my last element. Let me ask for the next element again. Then you will see an exception. What is like stop iteration exception, and on the basis of this exception, for loop came to know where it has to stop, because for loop, whatever the iterable you provide, it make a iterator internally, and then every time your iterate, every time the like you some write something for each value in this, every time your value point to a next iterator, like next iterator, go to next, go to again, go to next, go to next, go to next. The moment you find the stop iteration, this stop iteration exception, it say, okay, I have processed my list, I'm at the end, I'm good, let's end this loop, go out. So with the help of this exception, your for loop came to know where it has to stop. So this was the important concept. This is how the for loop work internally. And okay, yeah, I want to end the class, and I will upload the recordings. And in the next class, we will learn about tuple. Thanks. And in the next class, we will learn the tuple, and some people are confused. What is this bool and all? What is this bool? What is this flag? I will tell you. And I have to do some work as well, because I have to because this notebook is prepared up to sub concept. I have to prepare for searching and sorting as well. The time complexity, space complexity. So tuple we will learn, and then tuple, there's some tuple method. I guess we can able to cover tuple and sets in the next class on Saturday, and then we can able to use the we can able to understand the functions. And once we understand the functions, then after that we come to dictionaries, and after dictionaries the things are sorted. After that there will be um searching sorting class, which will again another take 2 days. After that, little bit of exception handling and object-oriented programming. And after that, you understood the whole Python concepts, then you will solve some questions. I will tell you where to solve questions, and then we will start other topics in data engineering. So you have to make a solid foundation on the Python, because other topics, you will see the same structure, same syntax, but those are maybe more conceptual, or those are maybe there's a more of a theory, because like how the airflow is working, there will be more theory inside them. And code is everywhere, code is always there. So this is how it will look like. So it will take your next to next 4 class, I guess, to complete this Python. And then for the rest of the topics, we will go with the other advanced concepts. Okay, cool. So yeah, thanks guys for your time. I will upload the recordings accordingly. Thank you.